Hi class, I hope you all had a fantastic Thanksgiving break. We are going to be starting some new information today. So it's really important here that as we're starting notes, make sure you are getting out notes, make sure you are following along. I am also going to link this info onto Canvas. So if you missed something or if you need to hear it again, feel free to go onto Canvas. It's going to be linked on today's day that you can go in and rewatch the video or sort of fast forward and rewind to whatever part you needed to hear again. For those of you who were not here on Friday, you didn't have any homework, okay, but you are going to want to make sure that you take time to watch the video from Notes on Friday that's over compound inequalities. Okay, that information is going to be on our test Thursday, so you want to make sure you're caught up there. So if at some point between today and tomorrow you have some extra time, you finish up something with this sub early, that should be the next place you're going if you were absent. So today's topic is going to be over literal equations. Literal equations is an overall topic that encompasses any time that we have something with multiple variables in it and we're rearranging to solve it for a different letter. Now, you actually see this quite often in science class, you just don't know. Because oftentimes in science class, you're working with the formula distance equals rate times time. And your science teacher will often give this to you in multiple different forms. So you'll see distance equals rate times time. You'll see rate equals distance over time, right? You'll see it sort of solved for the different letters. And the reason why that's beneficial is if you're doing something like an experiment, and you're having to do the same process and plug the numbers in multiple different times. Like I think some of you have been doing some things in science class where you're measuring the distance and then you're using a stopwatch for the timer or whatever, and you're plugging in distance and time to find the rate, right? You would have to keep solving that equation over and over for each situation. So instead, it's easier to just solve it for the rate and not have to solve an equation each time. So if we stick with that idea, instead of just being given the other option, let's say we decide to solve this for R. So we want to get R by itself. So this means solve it for R. Okay, so if we want to do that and we want to get R by itself, our first decision is, okay, if we focus on this side of the equation, what variable is over here with it? So we have R and T on the same side of the equal sign. So we need to get rid of that T to get R by itself. Okay, then the next thing we'll ask is, well, what operation is holding them together? So these are being held together with multiplication. And just like with any equation, right, we undo multiplication with division. So while it might feel more overwhelming that there's all these letters floating around, there's actually less work with literal equations because this T will cancel out and there's no computation. D divided by T is just D divided by T. We don't know what those are, so there's no math to compute. We have R by itself, so we might rewrite this to say R equals D over T, but we have now solved it for R. R is by itself. Okay, and that's the idea that we want to do for everything with literal equations. It just might have more steps to it. Okay, so let's look at one maybe a little bit more complex and say A times B plus C equals D. Now, this isn't a formula. I've just made up some letters. We often do this with formulas, but lots of formulas right now are going to be a little bit too complex for us to start with. So we're just going to stick to some made up things. And let's say we want to solve this for B. Okay, so if we want to solve this for B, we are focusing on this side of the equation sign because B is over here, and we're going to need to move the A and the C. Now, we want to use the same rules with solving equations, so we are still doing order of operations backwards. So if we're doing order of operations backwards, right, we're going to undo any addition or subtraction first. And this C is attached with addition and subtraction, so that's what we need to move. Now, if you feel really overwhelmed with all the letters, sort of a little trick you can do to sort of trick your brain for the moment is fill in the letters that we're not solving for with just a different number. Just kind of write lightly above it. Okay, and pretend for a moment if we were going to solve this, I think we would all agree that we want to subtract the 3. Okay, so then when we go back to the letters, you want to move whatever is in that same position. So if we were going to subtract 3, well, now we're going to subtract C. Okay, and whatever we do to one side of the equal sign, we have to do to the other. So no writing it over here, right? Once to the right side of the equal sign and once to the left side of the equal sign. So our C's are going to cancel out, which leaves us with AB. Again, no computation. This is just D minus C. So our next step, if we want to get B by itself, now we need to move the A. That A is attached with multiplication, and we undo multiplication with division. So I'm going to divide by A. Now, we need to make sure we divide this entire other side. Okay, multiplication and division work is something that goes all the way through the entire problem. So our A's are going to cancel out, and we'll just get B equals D minus C all over A. And while it looks weird, we have B by itself on one side of the equal sign, so we are done. So let's say maybe we have H minus Q equals W, and we want to solve this for H. So if we want to get H by itself, Q is what's sitting over here with it. We undo subtracting Q by adding Q. So I'm going to add that to each side of the equal sign. My Q's will cancel out. W plus Q just stays as W plus Q. I have H by itself, so that is my final answer. One last one here of this type. So here's a common formula. Area equals 1/2 base times height. Okay, so hopefully maybe some of you right now can tell each other what this is the formula to. Okay, but this is how we find the area of a triangle. Hopefully remember that from previous math classes. But let's say that we want to solve this for B. Okay, so if we want to solve this for B, we have two things to get rid of. We have a 1/2 and we have an H to get rid of. And oftentimes my students will think, okay, well, I'm just going to start moving one of them at a time. We can do that. Okay, but A, it's going to be extra work, and B, we're going to start getting this big fraction with multiple things being divided over here. So remember, we have this rule with multiplication, right? All of these pieces are being multiplied. We have a commutative property of multiplication that says it's okay to change the order, and we can multiply in any order that we want. So it would be okay if instead of writing 1/2 times B times H, we wrote 1/2 times H times B. And if it was written like this, I think then we would all agree that we could just go ahead and divide by the 1/2 H all in one chunk. So that same thing is going to be fair over here, that we can just divide this entire thing by 1/2 H because we are allowed to change that order with multiplication. So my 1/2 cancels here and my H cancels here. And realistically, if we are just asked to solve for B, if that's all we are asked to do and it is a free response, it would be a correct answer to say B equals A over 1/2 H. But hopefully the majority of us would agree that this isn't really a good way to write an answer, because having a fraction within another fraction is not good news, right? That's not how we write fractions. So it would be better if we could get rid of that sort of double fraction happening. And there's a couple ways that we can think about this. Okay, we can know that when we're dividing by 1/2, we are really multiplying by the reciprocal. So we're really multiplying by 2/1. Or we could also know that there's a 1 sitting up here in front of the A, and we could simplify 1 divided by 1/2. And 1 divided by 1/2 is 2. That's an H on the bottom, sorry. And so our better answer would be B equals 2A all over H. Now, while the idea of solving literal equations is really important, it is not actually our main goal with literal equations. Our main goal is that we're going to want to be able to solve for y. We're going to want to manipulate equations that later are going to turn into graphing. And we want to get them into our slope-intercept form, which most of you have probably heard of before. And we do that by solving for y. So the most common situation is we will be given something like 4x plus 2y equals 24. And so now we have a combination of both multiple letters and multiple numbers happening. And we want to be able to solve this for y. Okay, so if we want to solve this for y, again, I'm going to sort of replace the other letter with a number. So let's just pretend that this says like 40 plus 2y equals 24. And I think if we saw it in that format, we would agree that we're moving this entire chunk all at once. And that's exactly what we would want to do here first. Okay, to get y by itself, we are undoing any addition or subtraction. So I'm going to undo a positive 4x by subtracting 4x. And whatever I do to one side of the equal sign, I have to do to the other. Okay, so those are canceling out. I am then going to bring down my 2y. Now, it would be totally correct here for you to write this a couple different ways, but there's one that we're going to see more often. Okay, the first thing that we need to understand is that these two things are not like terms, so we cannot subtract them. So we're just going to leave it as 24 minus 4x. But the standard way that we write in slope-intercept form is with the x first. So we're going to kind of write this in reverse order. So we're going to write our negative 4x first and our positive 24 second. If you were solving by hand, you mathematically would not be wrong if you wrote in the other order. In the long run, you're going to be happier if you write it like this. Now, I am going to tell you this. There is a standard that says we should be able to recognize things in equivalent forms. Okay, so we should actually be able to answer like multiple things that are correct and the same representation. And maybe they went with the approach of writing the 24 first. Okay, so we need to understand that these are the same thing no matter what order we write them in. Okay, our next step, again, to get y by itself is going to be to divide by the 2. And just like we said before, we want to divide this entire thing by 2. But since we actually have numbers and not just letters, there is some math we can do here to reduce it. So it's going to be more helpful if we write that 2 in 2 separate places. Okay, and now we can just simplify, so that cancels out there. Negative 4 divided by 2 is negative 2. 24 divided by 2 is 12. And so our final answer would say y equals negative 2x plus 12. Okay, so everybody's favorite. What happens if maybe I throw a fraction into here? So what if I have 3x minus 1/2 y equals 8? Okay, and we want to solve this for y. Okay, so 3x minus 1/2 y equals 8. So if I'm going to solve this for y, again, I need to move that x. So this 3x is positive, so I'm going to undo that with a negative. Subtracting that from both sides. That's going to leave me with a negative 1/2 y equals a negative 3x plus 8, because that 8 is positive. And then I'm going to undo that negative 1/2, right? It's attached with multiplication. I'm going to undo my multiplication with division, and again, I'm going to divide in all 3 places. So our negative 1/2s cancel out. Now be careful here with your math. Negative 3 divided by negative 1/2 gives us a positive 6x, right? Dividing by 1/2 is the same thing as multiplying by 2. And a positive 8 divided by a negative 1/2 is a negative 16. And so we will get y equals 6x minus 16. Last one. Let's say we have y over 5 equals x over 3 plus 2, and we want to solve this for y. Okay, so if we want to get y by itself, the x isn't over there with it, so we don't need to move that x away at all. The only thing we need to do is get rid of this 5. Okay, and we undo division with multiplication. But just like with the division, right? Multiplication and division go all the way through. So we need to multiply this entire side by 5. So these cancel. Over here, we're going to have to distribute. And here's where, like, one piece is easy. This one's fine. 5 times 2 is 10. But be really careful here because we are not taking 5 times 3. There is really a 1 up here in front of the x. And so we really want to take 5 times 1/3. Okay, and that is going to give us a 5/3 x. Okay, so you are going to work on some problems here on your own. This video is linked on Canvas if you need to go back and watch it. When you are finished working on those problems, you are then going to also go into Canvas and complete the quiz, okay, where you're going to put in some responses to some of the work that you did, right? So I should be able to see the following things from you when I come back. I should be able to see the problems worked out with all of their work shown. And I should also see that you filled in the response in Canvas. If you do not get those both done in class today, then your job is to complete that for homework tonight. Okay, so get all that finished. Tomorrow you have a sub as well. You'll be doing a similar process, but we will be looking at absolute value equations. Have a great rest of the day, everyone.